Broadcast is now starting. All attendees are in listen-only mode.
Good morning and good afternoon, everyone. It's a pleasure to be connected. My name is Annie Vernig, and I'm a Knowledge Management and Capacity Building Specialist for the Nature for Development program at UNDP. I'll be your facilitator for this webinar today. Over the past 3 years, UNDP and NASA have worked together with top-tier researchers to generate new data on tropical forests that can be used by policymakers to meet their national needs. Working with 8 pilot countries, we have successfully tested the applicability of these spatial data. Now, in the project's final year, we're releasing these data to 21 additional countries with humid tropical forests. Next slide. This is the third and final webinar in our series to build awareness around the potential to use data from the Forest Integrity Project to support your country's conservation and climate commitments. Today, we'll start out with a review of the information we've shared through the previous webinars. The overall objectives of the project, what data is available through the project, and where you can access it. We'll then hear from our science team about general applications for each of the data layers produced by the project. The third portion of the webinar will present basic methods for how project data can be applied to address key policy questions related to the implementation of the Convention on Biological Diversity and the 2030 Agenda for Sustainable Development. As always, we'll have time throughout the webinar and at the end for questions and discussion. Today, we're excited to have here with us the science team who generated all of these data. We will hear presentations from Dr. Andrew Hansen, the director of the Landscape Biodiversity Lab at Montana State University, Dr. Patrick Jantz, who's an associate professor at Northern Arizona University, and Drs. Oscar Venter and Rajiv Pillai at the University of Northern British Columbia. Welcome, everyone. We're so excited to have you here today. As usual in our sessions, I'd like to remind you all of certain rules and dynamics in our webinars. Microphones will be muted during the presentation. This reduces interference and facilitates communication. Please send us in advance your questions or raise your hand in the control panel of GoToWebinar. If you want to speak and the connection allows it, we'll open your microphones during the question and answer sessions. As many of our participants are not native English speakers, I would like to remind our speakers the importance of talking slowly. This fosters comprehension among our participants from around the world. Finally, this webinar is being completely recorded and we will post it on the NBSAP Forum YouTube channel after the completion of the webinar. We'll also share this recording and our PowerPoint presentation over email. Next slide. So before I turn the mic over to our first presenter, I'd like to start out today with a recap of what we've covered during the previous webinars in this series. As you all may know, the NASA Forest Integrity Project brings together NASA, world-class researchers, and you to use the power of spatial data and science to support conservation planning, monitoring, and reporting. Our goal is to produce rigorous scientific data on tropical forests that can support UNDP and governments to take action to support climate and biodiversity priorities. Next slide. During our first webinar in October, we introduced data on tropical forests available through the NASA Forest Integrity Project. We also heard from 2 of our pilot countries, DRC and Vietnam, about how they used project data to support their conservation planning and reporting. During our second webinar in February, we trained you to use the UN Biodiversity Lab as a tool to access key global data, to upload national data, and to run basic spatial analyses. We also showed you how you can access, visualize, and download forest integrity project data on UN Biodiversity Lab. If you missed either of these webinars, don't worry. You can still access the recordings and presentations at the links shown on this screen. Next slide. As we've discussed in previous webinars, the Forest Integrity Project is producing 6 key data sets. 4 of these, which you can see in green, are already completed and available for your use. Today, we're excited to share that we have new data available on forest fragmentation, which is number 5 on this list. We now have data on fragmentation in high integrity forest patches available on our Project Figshare account. This is in addition to the data on fragmentation and connectivity between intact forest landscapes that was previously available and we shared during the last webinar. Finally, the 6th data layer on the impact of forest integrity on key species will be available in the coming months. Next slide. So following our first webinar back in November 2019, we shared 10 draft maps of project data with you for your country. For some project data sets, multiple maps are available. You can see the full list of maps we provided on this screen. If you didn't receive these maps for any reason or have questions about them, please don't hesitate to contact Scott Atkinson at the address shown on the screen. Next slide. So finally, I just want to remind you that in our last webinar, we showed you how you can visualize and download all project data on UN Biodiversity Lab. As you're seeing in this screen here, it's very simple to find project data on UN Biodiversity Lab. Simply click on the Forest Integrity Project filter, and you'll be able to see a list of key project data sets. From there, you can either visualize them on UN Biodiversity Lab or click through to download them directly from our Figshare site. Next slide. Great, so now that I've summarized some of the key topics that we covered in our first 2 trainings, I'll transfer the microphone over to our presenters from the science team, who will introduce the data that their lab has produced and provide a brief overview of how these data can be used to support implementation, monitoring, and reporting on key targets and indicators. So first, I'd like to pass the microphone to Dr. Andrew Hansen, the director of the Landscape Biodiversity Lab at Montana State University.
Welcome, everyone. So glad you're joining us. So we'll talk about the products from the FIP project, in particular how they relate to reporting for the Aichi biodiversity targets and some of the Sustainable Development Goal 15 targets. We more or less designed the project to contribute to the highlighted targets in green and orange in this slide. Specifically, the products can be used to define natural forest habitats, forest degradation, status of protected areas, connectivity, and fragmentation. And then we're additionally working on products relevant to threatened species, as we'll hear from Rajiv here later in the webinar. And again, later in the webinar, I'll show you some specific analyses that can be used to support reporting on the targets here. Next slide, please. To start to give an idea of the types of and uses of project data, let's look at some of the individual layers. You might remember that the first data set is on forest condition. This is the one generated at the University of Maryland by Matt Hansen's team. This basically involves canopy cover, time since disturbance, and canopy height. And next slide, please. These data, as you probably know, are being very widely used around the world for mapping forest extent, loss of forests, gain in forest, illegal logging, fragmentation, and connectivity. We encourage you to explore the web page indicated here for extensive descriptions of these data and how they can be used. And then the publications associated with the products are also available through the website. To talk about the next data layer, I'll turn the mic over to Dr. Oscar Venter.
Hi, everybody. If we can go to the next slide, please. So some of the early data we developed for the project was data on the human footprint, and we produced maps for the project that reflect the human footprint in the year 2000, 2005, 2010, and 2013. And these maps combine information or spatial data on human land covers, infrastructures, and access into remote locations. All these different data sets are combined into the human footprint map, which can be looked at as a reflection of the threats to natural systems from human pressures. Can we go to the next slide, please? So these maps can be used for national level reporting on the extent and intensity of human pressures. They can be used simply for visual interpretation, like we're doing now, showing locations of intensive human footprint and areas that are more intact. Or they can be analyzed to report on the extent of these different conditions across a country. They can also be used to report on human pressures within protected areas, which can be useful for some countries. And I just note that these maps do not directly show the ecological integrity of land or forests, but rather focus only on the intensity of humans using that land. So the later products you'll see by the other presenters will more directly measure the condition and integrity of natural systems. If you go to the next slide. So in addition to reporting on the state of human pressures across a country or a region, comparing maps over time, you can look at change in human footprint, highlighting locations where human footprints are increasing or intensifying, or even decreasing if people are leaving certain regions of a country and abandoning land and infrastructures there. They can also highlight areas where human settlements or cities are expanding into rural landscapes, or where agriculture may be expanding into natural environments. Also, these maps can be used to identify areas that are becoming more natural as people leave the landscape. Okay, next slide, please. So this is getting a little bit more complicated, but I wanted to flag this application. So human footprints maps, like the ones we were looking at in the previous slides, can be used to look at threats to endangered species. So if particular species are sensitive to human pressures and land uses, you're able to take the range maps of these species, so maps that show where these species exist within a country, and combine them with the human footprint maps to highlight places of potential biodiversity conflict. Okay, I think that's all I'm going to present, so I'm now going to turn over to Andy again.
Thanks, and if we could move on to the next slide. So the third layer shows forest structural condition, and we'll avoid the detail on the graphics here, but point out that that high forest structural condition index values basically help us to understand which places have tall canopies and full canopy cover and are older, having not recently been disturbed, so more typical of primary forest. And low index values indicate places that are low in stature or more recently disturbed. This layer is quite relevant with regard to several ecological response variables, particularly aspects of biodiversity and ecosystem services, and thus is useful for conservation planning. Next slide, please. Yeah, thanks. These applications would include mapping forest structure as a measure of ecological quality of forest, providing input to the degree of forest degradation, identifying locations for forest restoration, providing inputs into species distribution models, trying to map biodiversity storage, and then also contributing to analyses of hydrology and water cycles. So this is just an itemization of some of the potential ways that the layer can be used. And again, we'll give a more specific application here in a few minutes. We're happy to provide additional information on FSII and how it could be used for applications. So please don't hesitate to contact us if you would like more information. And if we go to the next slide, this is what we call Forest Structural Integrity Index. It's a product of combining the forest structural condition with the human footprint that Oscar just described to derive what we're calling forest integrity. And we, as we'll see in a minute, we identify these forests because we think they're of particularly high importance for conservation value. And the next slide will show this. So these can be used to identify the forests that are of highest quality in terms of well-developed structural condition, but low human pressure. They can provide a correlate of biodiversity value based on this intersection of forest structure and human pressure, and then a basis for conservation planning, allowing various strategies to be mapped, such as where to maintain current protections, where to add new protected areas, opportunities for restoring forest structure, and then for mapping where human behavior perhaps can be managed to restore forest integrity. And again, we're happy to provide more information to any of you individually, if you like. And I think we now go to the next slide, which Patrick will be discussing.
Hi, everyone. It's a pleasure to be here. And yes, I'll talk about forest connectivity and fragmentation layers and applications. But the idea behind these data layers is that in addition to understanding structure and human pressure in a specific spot, we also want to know something about the context or the pattern of high integrity forests or other forests of conservation concern. And that's what we have developed with these layers. And so for connectivity, we do things like mapping corridors between conservation areas of high conservation interest, like high integrity, intact forest landscapes. And we also do a pattern analysis of forests in general, and then high integrity forests. And we can move on to the next slide. For some of the applications of these data layers, we can classify forests based on the level of fragmentation. And so one important fragmentation class is core forest. And so this is a forest that is essentially far away from disturbance and is surrounded by other high quality forest. And then the opposite of that is, or on the other end of the spectrum, is patch forest. And that's forest that is small, fragmented, and isolated from other forests. And so some of the applications of these types of data layers is identifying core forest, where they are, identifying where forests are more exposed to edges as a way to identify risks to edge-sensitive species. And then we can also use corridor mapping to identify areas between intact forest areas or other conservation targets like protected areas to essentially try to identify places that can maintain connectivity between conservation priorities. And so feel free to contact me. My email is on the slide if you have any additional questions or would like to talk about these and other applications. And then I'll hand off to our next presenter.
Thank you, Patrick. Hello, everyone, and welcome to the webinar. It's a pleasure to be here. My name is Rajiv, and I'm going to talk about the final data set produced by this project. And I'll briefly right now talk about how the data set produced by this project will look at the impacts of forest integrity on key species ranges. Can we go to the next slide, please? Now, a main application of our project data is on connecting forest integrity, which Andy talked about, and the geographic ranges of key species to support conservation planning. I will give you an example of how we can use forest integrity to understand the state of a critically endangered species. On this slide, we see a species called the saola. It is a critically endangered mammal that occurs in the Annamite Mountains of Laos and Vietnam in Asia. And it was only discovered to science in 1992. So it's a fairly recently discovered species. Now, given that this species is like critically endangered, by looking at the amount of high quality habitat, when I say high quality, I mean identified by high forest integrity, as well as low quality habitat. Here it's identified by low forest integrity, remaining within its range. We can provide key information to PA managers or protected area managers and conservation practitioners. And we can also take an identical approach to look at any species across any of your countries. I will now hand over back to Annie.
Great, thanks so much, Rajiv, and thanks so much to all of you for summarizing the project data and applications. So Diego, next slide, please. Great. So on this slide, if you're interested on any more information on the data that's just been presented, you can see the publications that are available here. And as noted, we'll be circulating this presentation following the webinar, so you'll have access to these full citations if you're interested in going back to the original literature. Next slide. So with that, now that we've recapped the key project data and talked a little bit about some of the general applications for these data, I want to open it up to see if there's any questions at this point for the members of our science team.
I don't think we have any questions, any so far.
Okay, great. Well, then we will move on to the next section of the webinar. Diego, next slide. So the applications that we've discussed so far are highly useful, but we can also go beyond them to begin to monitor progress towards specific Aichi biodiversity targets and sustainable development goals. Next slide. For each of the Aichi biodiversity targets and the SDG 15 targets that Andy introduced at the beginning of this webinar, we can ask key questions to help us chart progress. So for example, answering the question, what has been the rate of loss of natural forests and high structural integrity forests, can help your country to monitor progress towards both ABT 5 and Sustainable Development Goal 15.2. In the remainder of this webinar, we'll go through each of the 5 questions you can see on this slide and provide an overview of the methods that would be needed to answer the question and show the results for a particular country. This is meant to provide an overview of the methods and potential applications for project data, but not to get to the level of detail that you would need to run these analyses on your own. If you or your technical team are interested in running these analyses for your country, please don't hesitate to reach out to us after the webinar, and we can provide more detailed methods and feedback. So to provide an overview of how we can answer the first question, I'll turn the mic back over to Dr. Andy Hansen. So next slide, Diego.
Thanks, Andy.
Great.
Right, so again, this deals with quantifying loss rates of natural forest and of high structural integrity forests. Next slide, please, Diego. And of course, this is relevant to Aichi Target 5 and Sustainable Development Goal 15.2. These are the data layers that we can use to address the question. They include those that are served by the project, along with other data sets that are publicly available, such as the data on ecoregions or in primary forests, as indicated here in the slide. Next, please. So there's let's first think about quantifying rate of loss of natural forests during this 18-year time period. We begin by defining forest in the year 2000. This has been done by the University of Maryland using particular thresholds for tree cover and canopy height in the year 2000. The thresholds they used were 30% canopy cover and height greater than 5 meters. This can be adjusted by each country if needed to define forest in a different way. The next step then is to identify which of the forest is actually, quote, natural forest. And this can be done by using low human footprint as an indicator of natural forest, or by using the primary forest layer that was developed again by the University of Maryland laboratory. So basically, we identify which of the forests in 2000 qualified as natural using either primary forest or low human footprint. And then using the year loss layer, we subtract places that have been deforested each year up to 2018 to track change in those natural forests. And then we can summarize those loss rates by ecoregion or by country using the ecoregion data set and the national data sets. So the next slide will show an example for just for 2 countries we selected somewhat at random, Colombia and Malaysia. In this case, we used primary forest as the base layer. This came from an analysis that had been done by the Rainforest Group, as indicated here on the slide. But it's easily replicated with tools like ArcMap or Google Earth Engine. And by looking at the bar graphs, you can see the sort of rates of change over that time period, which hopefully is very informative for getting at trends in change that can then inform conservation planning. Next slide, please. So we can now take the same general approach with regard to forests of high structural integrity. So there we go. Thank you, Diego. In this case, we can identify, we can map the high integrity forests and change in them, but for a shorter period due to data availability. For the period basically of 2012 through 2018. And the approach here is to first define forest structural index for the year 2012 using data layers for tree cover 2010, canopy height 2012, and loss year 2000 to 2012. So basically, we use those data layers and select forests that have canopy cover above 75%, above 15 meters height, and that have not been disturbed since between 2000 and 2012. So these are the high FSII forests at that time period. We then would use that layer with human footprint to then quantify areas of high structural integrity for that period of 2013. With that layer now, we can then subtract the places that have been lost during 2013 to 2018, and then summarize loss rates over that that period of time for places that are of these various forest classes: high SCI, high FSII, low SCI, low FSII, by country. I know we're covering a lot here, but hopefully by having more time to look over the slides, you can be sure to get the steps in mind to be able to replicate the analysis. The next slide provides, again, an example for Colombia and Malaysia of looking at these loss rates. So you'll notice, for example, in the table on the left side, that it's quite interesting to see that the rates of loss were highest among the lowest structural condition forests. And then the highest quality forest, the high integrity FSII forest, loss rates were substantially lower. This is likely a function of accessibility of the forests relative to proximity to roads or to cities. Because the high integrity forests are low in human pressure, they're probably more distant from roads, less accessible, and as a consequence have these lower rates of loss. So that's a very good news situation for conservation. It does provide us with perhaps some insights as to how to minimize loss of those forests, and that would be to try to avoid road building projects or other infrastructure projects that would increase accessibility to those forests. So I think with that, we'll go to the next slide and basically, Annie, see if there are questions concerning this.
Great, thanks, Andy. Marion, do we have any questions?
Not at this time still. Maybe let's give just a couple of seconds for people to ask if they have any question. No, it doesn't look like it. So we can move on.
Okay, great. So to cover our second question then, I will turn it over to Patrick Jantz at Northern Arizona University.
Thanks, Annie, and everyone. Yes, so I'll be focused on the question of whether forest fragmentation has been reduced generally and whether high integrity forest fragmentation has been reduced. And I'll show a couple of examples of how we might think about answering those questions in support of Aichi targets and sustainable development goals related to forests and sustainable use of forests. And so the data needed for these analyses comes primarily from the project, and that includes tree cover information for the year 2000, the year of loss from the year 2000 to 2012, whether there has been a gain in forest cover from 2000 to 2012. And then to look at high integrity forest fragmentation, we need information on the Forest Structural Integrity Index. And one way to summarize these results is using ecoregions, although they can be summarized at various spatial scales depending on the unit of analysis. So next slide. Thank you. And so the steps to this, so we'll divide this question into two parts. The first looks simply at global forest cover, and then the second looks more specifically at high integrity forests. And so these are slightly different applications. But in any case, the fragmentation analysis requires a binary map to to work with. And so that could be something like forest or non-forest, or high integrity forest and not high integrity forest. So for the data layers we provide through this project for global forest cover, we use a definition of forest of either 25% canopy cover or 50% canopy cover. And so this application doesn't distinguish between natural or non-natural forests. Instead, it's meant to quantify patterns of any forest cover more broadly. And then the next step is to use software called GUIDOS, which categorizes each forest pixel into one of 5 fragmentation classes. And just quickly, the main fragmentation classes are core forest, and that is any forest that is greater than some specified distance from an edge. And that distance corresponds to how far you think edge effects propagate through the forest. And studies have shown that that can be anywhere from a few meters to several kilometers. And so for these data layers, I provide edge effect distances of 500 meters and 1,000 meters, just to capture a couple of different potential edge effect scenarios. And so because core forest is buffered by surrounding forests, it's least likely to be affected by human disturbance and is most likely to contain a full complement of interior forest species. And then the next class, perforation, consists of forest pixels that are next to small gaps within core forest, and the gaps can be either natural or anthropogenic. The next class is edge. An edge forest forms the boundary between core forests and the broader landscape. Matrix forest extends from edge forest into the broader landscape and is totally edge affected. And then patch forest is also totally edge affected, but it's also isolated from all the other forest types, so it tends to occur in small patches. Essentially what we do is we use the GUIDOS software to categorize forests in 2000. And then we use the loss year and forest gain information to map forest pixels for the year 2012. And then we can reclassify those pixels using the software for the year 2012. And then in that way, we have fragmentation classes in the year 2000 and fragmentation classes in the year 2012 that we can compare to look at some trends. And so next slide, please. Thank you. So question of, has fragmentation been reduced from 2000 to 2012? Results for South America indicates that fragmentation has increased. And this is because we see that, for example, for using a 25% forest threshold and assuming an edge effect distance of 500 meters, that core forest in South America, Africa, and Asia decreased by 10%, anywhere from 10% to 25%. And this is fairly similar to the results using 50% threshold to define forests. And then matrix forest, which tends to be more edge affected and is, we consider it more fragmented, the amount of matrix forest increased anywhere from about 12% to 22%, depending on the forest threshold and the region. And so on the right, we can see maps of this for South America and Central America, showing those fragmentation categories: core in green, perforation in blue, edge in black, matrix in red, and then patch in the light brown. And so most of the apparent fragmentation at this scale has occurred in the arc of deforestation in Brazil. But yeah, overall, the trends indicate that fragmentation of forests in general has increased across most of the regions. And we have these data available for all the 29 countries. So next slide, please. Okay, thank you. And so the next question related is, has high integrity forest fragmentation been reduced? So we use a similar approach. We use the methods that Andy described to identify high FSII forests, so Forest Structural Integrity Index forest, a combination of structure and human pressure. And we use a threshold of 14 for forest structural integrity to basically divide forests into high integrity forests and not high integrity forests for the year 2013. Then we can use Guido software again to classify high integrity forest into one of those fragmentation classes. And then we can calculate the area of those fragmentation classes in specific areas. In this case, we'll show a few different ecoregions across the tropics. And then what we can do, we don't have change in high FSII forests specifically, but we do have areas of forest loss between 2013 and 2018. And so we can overlay forest loss from 2013 to 2018 onto each of the high FSII fragmentation classes to identify where deforestation has occurred in those classes. And we're primarily interested in whether deforestation has occurred in that core forest class, which tends to be the least disturbed and we think most valuable for biodiversity. And then with that information, we can calculate area of loss and percent loss of each high FSII fragmentation class. And so the next slide. Thank you. And so here are some example results for 3 ecoregions in South America, Africa, and Asia. So the top left shows, outlined in black, Madeira Tapajós moist forest in Brazil. Top right shows, excuse me, Northeast Congolian lowland forest in DRC primarily. And then the bottom panel shows Borneo lowland rainforest that spans countries of Indonesia, Malaysia, and Brunei. And the fragmentation classes are shown here with a slightly different color scheme than before. But again, core forest is that green color. And the more fragmented classes will be in the orange and yellow colors. So you can see the large scale patterns of fragmentation in these maps. And you can also see that core forest varies considerably across these ecoregions. And this is showing an analysis using a 500-meter edge assumption. And it also ignores very small gaps, so those that are less than 1 hectare in size. But we provide layers that don't ignore any gaps. They ignore gaps of 1 hectare in size or ignore gaps of 5 hectares in size. So you can look at different scenarios of what you think a fragmenting gap, size of a fragmenting gap might be. Okay, the next slide. Thank you. And so these are graphs showing a couple of the quantities that I mentioned before. So the top row shows the amount of each fragmentation class that was deforested between 2013 and 2018 in each of those 3 ecoregions. So we can see that, for example, hundreds of square kilometers of core forest was lost in the Madeira Tapajós forest in Brazil. Core forest loss was lower in the Congolian lowland forest and the Borneo lowland rainforest. And in general, matrix forest and patch forest overall amounts tended to be higher than the other classes. But what's interesting is if we look at the bottom row, we can look at the loss rates as a function of fragmentation class. And what this shows us is that in general, matrix forest and patch forest, and to a lesser extent, edge forest, are at greater risk of deforestation than the core and perforation classes. And so this provides us additional information above and beyond human pressure and vertical structure, because we've essentially isolated high integrity forests. But then with this pattern analysis, we can look at whether there are specific places within high integrity forest that are at higher risk of loss than others. And that's what this shows. It also shows that in general, fragmentation increased because there was deforestation in core and perforation classes, which will tend to increase the area of edge, matrix, and patch forest. And so with that, I will take any questions.
I'm giving a few seconds for people to just formulate their question and then ask them if any. I don't see any questions from Patrick and Annie, so you can go ahead.
Great, thanks, Marianne. So I think Patrick will also take question 3, which looks at the question, has connectivity of protected areas increased?
Yes, thanks, Annie. Yes, so we have an additional question that we're interested in. And we have data layers right now that we can use to answer one aspect of this question. And so I'll describe that here. So next slide, please. And so we need, again, some key data sets from this project. The first is tree cover in 2000, and then we need loss year from 2000 to 2018. And we don't have results for this yet, but we'll need forest structural integrity index data as well when we look at corridors and connectivity between high structural integrity areas. And then for this example, I'll show some results that use intact forest landscape information, and then also World Database on Protected Areas information. But this analysis could be run using any national protected area data, because I know that the WDPA may not be complete or as accurate as some national data sets. Okay, next slide. So the basic steps for this example, which speaks to Aichi target 11 about connectivity of protected areas, is first we mapped corridors between intact forest landscapes in the year 2000 using a least cost corridor approach, which prioritizes high tree cover corridors. And we mapped many corridors, thousands of corridors between each conservation priority. And we end up with a map of the density of corridors between intact forest landscapes in this example. But then what we can do is identify intact forest landscapes in 2000 that overlap with protected areas from the World Database on Protected Areas. And there are actually a lot of these overlaps because intact forest landscapes, they're large areas of forest with minimal evidence of human disturbance. And so they tend to be larger than 500 square kilometers, and these tend to also overlap with well-managed protected areas. And so just to note, we're in the process of running this analysis with high FSII forests, and so we'll have that available later. But we can move on to the next slide to show an example result in Peru. Thank you. And so after we map those corridors in the year 2000, we can overlay forest loss from 2000 to 2018 to understand where tree cover loss has occurred within corridors between intact forest landscapes that overlap with protected areas. And so in this case, we're showing corridors that support connectivity for Manu National Park and the surrounding protected area complex in Peru. And so in the map on the left, we show light blue polygons outlined in black are intact forest landscapes. The corridor density surface is shown in green, and so darker areas are more important for connectivity or for maintaining connectivity, and lighter green is less important. And then in kind of red and orange, we show where deforestation has occurred from 2000 to 2018. We can see that deforestation has occurred in some areas very heavily and not so much in other areas. But what we're interested in is where tree cover occurred in corridors between intact forest landscapes in this area. And what we see is that in the early 2000s in the graph, annual deforestation was around 5 to 10 square kilometers within corridors between intact forest landscapes. And then by 2018, that had increased to anywhere from 20 to 25 square kilometers per year. So what this shows is a very strong trend of an increase in deforestation in corridors that support connectivity in intact forests and protected areas in this landscape. So what we see in this specific case is that connectivity is decreasing in this landscape. And so that's an example of how we can use these data to answer some of those questions related to Aichi target 11. And so next slide, please.
Great, thanks so much, Patrick. So any questions from our audience about this third application of project data or how it could be useful in your country?
It's still no.
All right, sounds good. Well, let's move on to our fourth question then. Next slide, Diego. So our fourth question looks at whether the status of threatened species has been improved or sustained. And to answer this question and its associated analyses, I'll turn the mic over to Dr. Reggie Pillay, who's a postdoctoral fellow at the University of Northern British Columbia.
Thank you very much, Annie, and hello everyone again. I will answer this particular question, and to do so, we are going to use a proxy, which is basically how much area in square kilometers of high FSII forest remains within the geographical range of the Saola. Next slide, please. Sorry. If you remember, the saola is a critically endangered mammal that occurs in the Annamite Mountains of Laos and Vietnam in tropical Asia. And as a reminder, as all of the other presenters have stressed, high FSII forest is defined as tall, multi-layered, closed canopy forest with low human pressure. So by demonstrating the amount of suitable habitat, that is high quality forest, within the range of the saola, we can help report on its status. And to put this in perspective, to answer this question, we will use two data layers from this particular project, the SCI and FSII raster layers. We will also use the IUCN range maps, which are available for free at the address at the website shown above on this slide. Next slide, please. So how do we run this particular analysis? How do we show how much high quality forest is remaining within the geographic range of any species? First of all, we downloaded the geographic range of the saola from the IUCN Range Maps database. As I said before, these maps are available for free for everyone on the IUCN Red List website. What we did with this range map of this species is that we overlaid it, or we added it on top of the FSII raster layer for 2018. Now, the FSII raster layer has pixel values that range from 0 to 18. 0 is a highly degraded forest with very high human pressure, and 18 is really high quality forest, that is highest structural condition forest with the lowest human pressure. So for this species, for the saola, we determined the number of pixels in three categories, that is low integrity, that is pixel values ranging from 0 to 5, medium integrity, which is pixel values ranging from 6 to 13, and high integrity, which is pixel values ranging from 14 to 18. And then we calculated the total area in square kilometers in each of these three categories. Next slide, please. So to repeat this, you can see each of these steps listed above. First of all, you download the geographic range of the saola from the IUCN Red List, or you can do that for any species. You overlay the saola range on the FSI 2018 raster layer, and then you determine the number of pixels in the three categories of FSI, that is low, medium, and high. And finally, you calculate the total area in square kilometers for each of these categories. Next slide, please. So our analysis showed that for this critically endangered mammal, only around 2,000 square kilometers of high integrity forest is remaining within its geographic range in Laos and Vietnam. So the vast majority of the range of the saola consists of highly degraded forests and is under immensely high human pressure. So this particular slide shows the results of this analysis for just one species. We can do the same thing for every species of mammal, bird, reptile, and amphibian that occurs in tropical forests. Next slide, please. So we did this for every species of mammal, bird, reptile, and amphibian. And just some brief results here show that across all of these four categories of taxa, South America, basically the Brazilian Amazon, has the highest amount of high integrity forest remaining for all of these four taxa, whereas comparatively speaking, the amount of high FSI forest in Africa and Asia is much lower. So the Amazon essentially represents the last stronghold for many of these taxonomic groups. And with this, I will take any questions. Next slide, please.
I don't think we have any questions so far, Rajiv.
Okay, I can hand over to Annie.
Great, thanks so much. All right, next slide, please, Diego. So for our final question, we'll look at how high structural integrity forests can be sustained and restored. And to talk about the analyses to address this question, I'll turn it back over to Andy Hansen.
How's everybody doing? We're at the last question. We're close to wrapping up. Appreciate your attention and patience throughout. This largely is aimed at how can one organize a suite of protection and restoration strategies aimed at providing high integrity forests and restoring them. We basically use the same data layers that we described earlier. And then additionally, we're using biome boundaries. Yeah, thanks for advancing. And the World Database on Protected Areas. And if we go to the next slide, we've outlined in a manuscript that's in review right now this basic strategy that's indicated in this table. Again, there's 4 different components of this overall framework. That is to maintain current protections, to expand protected area coverage, to restore structure, and to restore integrity. So the maintaining protections, of course, would occur in places that are currently protected and that are high in structural integrity. That is, they're high in structural condition and low in human footprint. We know that protections are being lost in many protected areas around the world, and hence incentives for local communities to try to maintain protections, added regulations, active management. These are all ways to try to maintain those protections. The second strategy would be aimed at those locations that are not currently protected but have high structural integrity forests. And this could be accomplished through tactics such as taking advantage of these locations when enhancing connectivity among current protected areas, and also working with indigenous communities and other communities to try to maintain, to create protections within these areas. The third strategy is aimed at trying to basically grow forests of higher structural condition. This would be focused on locations that have moderate levels of structure currently and low human footprint. And so reforestation becomes a tactic of interest here, agroforestry, and then managing fire and grazing to favor forest regrowth. The final strategy really deals with human behavior, and this would be in places that have high forest structure and moderate human pressure. And the opportunity here perhaps is to use education, citizen science, other types of incentives to encourage people to have a lighter touch on the forest, to, for example, try to reduce illegal hunting, to allow large mammals to reoccupy these forests that otherwise have high structural condition. There's an ability, of course, for us to modify these particular specific criteria to meet interests of within your country with regard to these types of strategies. So we're happy to discuss with you those types of modifications. And if we could go to the next slide, we'll have just an example again for Colombia and Malaysia of where each of these 4 strategies could be laid out on the ground, and the proportion of current forest area that is within each. And just note that within, I guess these 2 countries illustrate that each country has opportunities. In the case of Colombia, the largest land area, forest area, could be used for trying to expand protections. Some 44% of the current forest area would meet the criteria for that. And on the other hand, in Malaysia, the largest opportunity is to try to do that modification of human behavior in order to restore integrity. So again, there's opportunity for each country to try to improve forest structural integrity through one of these 4 strategies. And with that, we'll go to the next slide and take any questions you might have about this.
I am giving a few more seconds, and I would strongly encourage everyone to ask their question now, as we have all of the experts here to answer any of your questions. But Annie, I think it's good. I don't think we have any questions for now.
Okay, next slide, Diego. And next slide. All right, great. So similar to what Marion said, I just want to emphasize that today we have almost all of the science team here with us who's worked to create these data layers and to think about how they can be used to support your country's work towards the Convention on Biological Diversity and the 2030 Agenda for Sustainable Development. Next slide, please, Diego. And we also have several members of our UNDP Nature for Development team who's worked closely with you as well as the science team to think about how these data can be used to support action at the science policy nexus. So we have both the science team and members of our UNDP team here. So if there are any questions about how this data can be used in your countries to support projects or monitoring, we're happy to respond to your questions. So one last chance before we close the webinar, please let us know if you have any questions about the data or applications covered here today, the project in general, or how you might be able to use data such as these in your countries. We're happy to take your questions.
No, I don't think anyone has any questions for now.
Okay, great. Next slide, Diego. All right, so with that, I'd like to thank all of you who joined us for this session today. We'll be posting the webinar recording on the NBSAP Forum YouTube channel and sharing all of the presentations on NBSAP Forum and in our next email blast. We encourage you to reach out to any of our team here with questions about what we presented today or the project in general. We're really happy to work with you to see how these data can support your country to take action. So we hope you all enjoyed this webinar and have a nice day or evening. We look forward to your active engagement with the data provided through the NASA Forest Integrity Project in your countries. Thank you.